You in an Airbnb, or how does it work when you go to a different city?
Right now I'm in a hotel in Vegas, but it's actually an interesting concept. It's like a Airbnb inside a hotel. So apparently you have an option to buy a room, like as a condo in a hotel, and then people who did it rent it out as in Airbnb. And this is a good way to avoid the resort fees.
Very cool. Okay, so I am going to get us started, right?
Yeah.
Broadcasting now.
Hey guys, thank you for joining. I'm gonna wait for like 3 or 4 minutes before I start to let more people join us. So we are gonna start in about 2 or 3 minutes. Let's wait for 1 more minute and then we can start. thank you very much for the feedback. Akazon, I probably don't pronounce the name right. Appreciate the feedback though. Cool. So, hey everyone, welcome to the last episode in the OWASP API security webinar. I'm really excited for this episode because this one talks about the attacker perspective on API security. So, first of all, thank you so much for joining us. My name is Inon Shkedy. I'm the head of security research at Traceable. And I have with me Renata, who is the head of product. And I also have with me, if you can see here, Charbonder is my hacking bud. Every time I do some hacking stuff, he joins me. I think he's gonna be quiet this time. So just as a reminder, we had this series of webinars. We talked about the OWASP API security project. We talked about in the previous episode, we talked about the project's background and the OWASP Top 10 for API. We saw each one of these vulnerabilities, including some real examples from the recent times of API exploits in big companies. If you didn't have a chance to watch them, we will send you a link after this webinar so you can get access to all the recordings. So after we covered the OWASP Top 10 for API, and we understood a little bit about modern applications and how they are different than traditional applications, today I want to talk about a different aspect of API security, which is how you can leverage the new nature of modern applications as a pen tester or as a bug bounty hunter, and basically how you can perform a better pen test for APIs. So the agenda for today is, first of all, to talk from a high-level perspective about API pen testing. And just to let you know, this is not like some type of training that's gonna provide you all the steps from scratch. It's not like for someone who doesn't have any experience. Like, you need some basic experience in pen testing to understand the context here. We might in the future publish more webinars, which is more for beginners and people who just start their path in bug bounties. We're also going to talk about how to find the OWASP API vulnerabilities, how we can leverage the predictable nature of REST APIs to perform a better pen test, and what we can do if we got stuck during a pen test for API. Those two aspects are very interesting. Especially the last one. Many times people, when they perform a pen test for APIs, at some point they feel that they tried everything. So I'm going to give you some tips how you can try to make progress and to find more attack surface. So before we start talking about API pen testing, I want to talk about the mindset. From more a philosophical perspective, how you should approach API pen testing or in general pen test. So in my opinion, there are two types of pen tests, and I'm saying it as someone who performed probably hundreds of pen tests for different systems and applications in the last 8 years. So as I said, there are two approaches. One of them is you try to break into an application. You try to find vulnerabilities. You usually follow specific rules. You try to sometimes use automatic scanners and so on. And the second approach, which is in my opinion more interesting and usually leads to more interesting vulnerabilities, is to try to get into the developer's mind. So what does it mean? You need to try to basically understand what was the intention of the developer. If you understand the intention of the developer, you should think about it. You want to understand exactly what the application does, as if you were a software engineer in the same company. If you take this approach to understand better the behind the scenes what happens, it gives you an opportunity to find more interesting vulnerabilities that exploit the business logic of the application, that are less trivial to find, and potentially to find more critical vulnerabilities, and also to get more bug bounties. So how can you read developer's mind to understand what was the intention of the developer? So you should think like a developer. And one tool that can help you a lot with achieving that is to start coding. I'm not saying that you should be the best developer and you should understand all the design patterns, but it's very important if you want to be a successful pen tester to feel comfortable with reading and writing code. Again, it doesn't need to be like with a lot of like, you don't need to be the best developer, but you need to feel comfortable with code. Another concept that helps me a lot with APIs is mindfulness. This is something that I learned after I moved to California. I learned the concept of mindfulness, and it's a very interesting concept. Personally, it changed my life, but also it can help you to be a better person, but also to be a better pen tester. So let's see how we can leverage some of the concept in mindfulness to be a better pen tester. So the first concept is beginner's mind. This concept in mindfulness tells you that you need to be curious about anything in life and to approach everything with curiosity, basically like a child. So the same thing applies for API pen testing. Every time you see traffic between clients and APIs, you need to start asking yourself a bunch of questions about the traffic, like a kid, like that seeing new stuff for the first time. Don't take things for granted. We're going to see a few examples how you can be more curious about APIs. But in a high level, when you see an API call, like if you click a specific button on the Uber app and you see an API call, you don't really understand what is the purpose of this API call, you should try to understand it. You should like approach it with curiosity and like instead of like saying, it doesn't matter, you should understand each one of the API calls. You should understand what are the parameters sent to the API and what is the response and how it impacts the business logic of the app. And the second point, I know it's very comfortable if you perform a pen test to an app and you have a GUI. You have like a UI application that you can use. It can be mobile, it can be a web app, and you can just click a bunch of buttons, and it's very convenient to to generate traffic without like generating API call from scratch. But in APIs, it's sometimes you can do it. Sometimes you have like applications, sometimes you have the mobile application, but many times, especially if we talk about B2B APIs or APIs that you don't have clients to. For example, if you perform a pen test for an application for like a company and they have a mobile API, but you don't have access to the mobile client. It happens sometimes. You still need to feel comfortable to use the API, even if you don't have the UI. It's very important. So don't let fear stop you from generating API calls from scratch. So let's jump into practical tips, how you can exploit the OWASP Top 10 for API. And we're gonna start with the most critical API vulnerability, broken object level authorization, or the previous name, IDOR. And I'm gonna give you some tips how to exploit it. So the first thing we need to understand about BOLA is that BOLA is about viewing a resource that doesn't belong to you. Okay, in this example, this API endpoint might be vulnerable to BOLA. And before you start like changing the IDs, before you start like trying to exploit BOLA by accessing objects of other people, I want you to understand the language, like in what language you should think about exploitation of BOLA. So in this case, a resource is exposed through an API to me. Let's try to see each one of these components. So the resource, as we said, it's a photo. The API is the editor API. You can understand it based on the URL. And who is me? It's a very philosophical question, but in this case, it's the user with the user ID of 8581 and the role of regular user who is using the mobile client. After you understand those like components, those like full, very abstract components, you can start expanding the attack surface. Let's see how we can do it. So first of all, interesting example. So if you're trying to find Vola to get access to a photo of someone else, but this endpoint to expose the photo isn't vulnerable to Vola, you change the ID from 7 to 6, and you don't you get like access denied. There are more things that you can do. One of them is to find encapsulated resources. So what does it mean? Let's say that you have an app that allows you to create a photo album, and this photo album contains photos. So if you find a Vola in the album resource, you can still steal photos of other users by accessing albums of other users. So it's important to understand the hierarchies between the resources. And then it would be very beneficial to list all the endpoints to expose the resource or the encapsulating resource. So in this case, we might see that there is another endpoint to access photo 717 if you change the version from 1 to 0. And also, maybe this API call to editor API/photos, this is something that is called when you try to view a specific photo. But also, you can find a button on the web application or the mobile application to export a photo or to convert a photo to a different format, for example, to PNG. And it's a different endpoint. So if it's a different endpoint, it might implement different authorization checks. So you should check all the endpoints that access the same resource and receive an ID in the URL. So give it a chance and try to access the export photo endpoint. It also might be vulnerable to Vola. And the same thing about export album. Because as we said, albums contain photos, and it also might be a way for you to leak photos of someone else. When you talk about the clients, you can ask yourself, can you use other clients, other types of clients to access the same resource? So many times you can see in APIs that they have many types of clients, and each client might access different API. So if the web application would access API/export album, the mobile application might access mobile/get photo/717. So I encourage you as a pen tester to try to understand all the clients types that can have access to this application and to use all of them, because many times they use different APIs or different API endpoints. One interesting tip that I can give you is that the trivial use case is to find the web application and the mobile. But many times, especially if we talk about big companies, they also have a different application when you access the web application using mobile. So if you just like open Chrome on your mobile client on your like iPhone and access the website, this is like, for example, in Pinterest. If you access the mobile if you access the web application on the mobile, it would be a different API. So in terms of Vola, there are many, like if you see an endpoint that might be vulnerable to Vola, like this photos/717, and you want to understand if this endpoint is vulnerable to Vola, there are many approaches you can take. One of them is just to try to guess IDs of someone else, to change the 717 to 716. But there is a more sophisticated way to do it, because the previous approach might fail, especially if we talk about GUID IDs. Instead of like numeric, you have GUID. So what you can do, instead of like just guessing IDs, you can do something that I call session label swapping. So session label is every string that is used by the API to identify a user. It's kind of a generic term. It can be an authorization header with a JAWS token. It can be a session ID. It can be anything else. It doesn't really matter. As long as this ID, this is the one string that is used by the API to understand who is the user. So what you do is to create two different users in the app. Then you go to the victim user and you access a photo that belongs to you, and other people shouldn't have access to it. And then you create a different user who is like to simulate the attacker. And you take a look at the API traffic and you copy the session label. And then you go to the API call from the victim, you duplicate the traffic, and you change the session label to the session label of the attacker. And you just send it to the API to see how the API processes the request. If you get the same response, So the API is vulnerable to both because you managed to get access to this ID using the session label, using the identity of the attacker. Some random tricks that might help you to bypass authorization mechanisms is to wrap the ID with an array this way. Another cool trick is to send the ID twice in the URL. The first one would be the legit one, and the second one would be the ID of the victim. So this one would be an ID that you have access to, and the second one would be an ID that you don't have access to. Some of these tricks might work for you, not always, but sometimes, because different components and different microservices might use different parsing mechanisms. Especially if we talk about the microservices world, the authorization component might be written in Python or in Node.js. And then the API endpoint itself, that doesn't implement the authorization mechanism. It means that after a successful authorization, your input would go into the second microservice to extract the details itself, like to give you, like, for example, the photo. And this microservice might be written in a different language, like .NET, for example. And the interesting part is that sometimes those frameworks, like if you compare Node.js and .NET, they might use different JSON library parsings or different URL parsing. And the first microservice would take the first ID, and the second microservice would actually take the second ID, just because the parsing libraries that they use. A few other random tricks. If you see an ID in the URL, for example, photo, like API/photos/ like with the query parameter of ID, you should try to move the ID from the URL, from the query parameters to the body itself. Sometimes it would help you to bypass the authorization mechanism. And also a good tip that I can give you is that IDs in the body of the HTTP call tends to be more vulnerable than IDs in the query parameter or in the path parameters. Now I want to talk about excessive data exposure. We talked about this vulnerability in the second webinar, and it's one of my favorites because instead of like performing a complex pen test and like complex exploits, you can just take a look at the API and to see API endpoints that leak PII by design. So let's give you some tips how you can exploit this vulnerability, because it doesn't require you to send like sophisticated payloads or something like that. You just need to take a look at the traffic and to see if the API returns PII of someone else. But let's see how you can exploit it. So the challenge with exploiting excessive data exposure is to understand the context, to understand the hierarchies between users, roles, and resources, and to understand the hierarchies between different resources. So let's give you an example and how you can like navigate this resource maze. So you have this API call to Rides API/myRide. It might be like some ride sharing app, and the response contains like your previous rides, right? And you might take a look at this and like say, okay, it sounds very interesting. But as I said, API pentest requires you to be more curious, to be more mindful about the API. So what you can understand from this response is, first of all, that behind the scenes, you have the resource of rights in the API. Like this is the business logic of the application. This is the implementation of the application. As I said, you should think about the application as a developer. So you can understand from the response that there is the concept of a resource of a ride. And this resource encapsulates in itself the resource of a driver. And driver encapsulates the resource of a car. So these are actually three different resources, potentially three different tables on the database. And you can take a look at the API response and to see, okay, I don't see any PII in the ride object, in the ride resource. I don't see any PII in the driver because it's only the first name. But then with the car object, I can see something that I don't really know what is VIN. So you need to run a Google search. If you don't know, and by the way, this is an example from a real application that I tested. I saw the response of like which is the parameter of VIN, and instead of saying, okay, it doesn't matter because I don't know what is VIN, it just looks like random and weird, I just Googled it and I found that VIN, it's like vehicle identifier. It's basically the ID, like the MAC address of the vehicle. And this is something sensitive. This is something that the API should not expose. So you need to be curious about each one of the parameters. But let's say that you want to basically to expose to find excessive data exposure that would help you to expose the more information about the driver, right? Because you want to steal the information of the driver, not just the VIN. So the way you should think about it is, okay, I want to expose the information of the driver. Let's try to find more endpoints that expose rides. And we know that ride contains the driver object. And the beautiful thing about API endpoints is if you have different endpoints that expose the same resource, like it might be developed, like those two endpoints or more than two endpoints might be developed by different developers and different teams. And different developers have different security standards or different security understanding. So in this case, we saw a developer that exposed, that wrote the API endpoint of rides API slash my rides. And he actually didn't expose sensitive information about the driver itself. But the developer here have different like security understanding. And he actually, like the developer who wrote the get slash write API slash export write, and he actually returned the full name of the driver, which is PII. So this is one example how you can find like a different endpoint to expose sensitive information about something about a resource that you want to test. So let's talk about API predictability. One of the things that you can leverage as a pen tester is the predictable nature of REST APIs to basically to perform better pen tests. And I can give you a few examples what you can do with this predictable nature. First thing, you can use this nature to find admin endpoints. This is pretty simple. In the case of traditional applications, if you take, for example, some type of monolith ASPX application in .NET, if you wanted to find the admin endpoint, you would need to guess this whole URL, /app/admin panel/user management.aspx. You would need to mention the action and the user ID. Even if the developers didn't implement access control and you could access this endpoint as a regular user, it would be very hard for you as a pen tester to guess this whole thing because it's kind of random, right? It's not like a specific predictable structure. So in the case of, fortunately, in the case of APIs are very clear. It's very easy to predict how the admin endpoint would look like. So let's say that you have an endpoint that is accessed by your mobile client of get/API/user/user ID. This is something that you should have access to as a regular user. And you want to find the endpoints to delete the user. And like in this case, to delete a specific user, it's a function that should be accessed only by admins. So instead of like guessing this whole thing, like this whole URL, you can just change the HTTP method from get to delete, and you expose an admin function. And it happens because of this is how developers should write APIs. This is the standard. If you have two different operations on the same resource of users, you should just change the HTTP method. So this is very helpful as a pen tester. Let's see how we can find hidden features in APIs. So many times when you take a look at API responses, you don't really pay attention to the details. And this is something that you should do. You should pay attention to the details. And one example that I personally found in one of the ride-sharing apps is basically, I saw this API response. I took like a ride in my, like using the ride-sharing app, and the API response of get/rides API/last ride contains the payment options. And the thing is that I didn't really, I mean, I paid only with one credit card. But if you take a look here, you can see that this payment ID, this is the ID of my credit card, is not inside, it's not like represented as a simple string. It's actually inside an array. And there is a reason why, like if you see something like that, the first thing you should ask yourself is where is the payment splitting option, right? Because if the API response contains a payment option inside an array, it means that there is an infrastructure to enable more than one payment option. And it probably means that the API supports payment splitting. And the next thing that I would try to do personally is to try to find the feature on the UI to split the payment, because it sounds like an interesting feature that can help you to like maybe find other vulnerabilities. Another tip that I can give you is to find the most niche features. If you perform a pen test for an application, it's not only API, by the way, it's every type of application. I wouldn't be focused on the main endpoint. So if we talk about Facebook, if you have like the endpoint of post comment, it's less likely to be vulnerable. Why? Because these are the main endpoints, and developers usually tend to invest more resources in more code reviews when it comes to the main endpoints that many people use. And also other pen testers probably already tried to exploit the main endpoints because these are the most obvious ones. So they are more likely to be protected. The trick is to find the most niche features. Like try to dig deep into the UI and to find the features, the buttons that nobody actually uses. For example, if you have a feature to add Christmas greeting to your profile that is exposed only a month every year, and to be honest, I don't think that everyone actually does it. Like it's something very specific. It's like nobody probably accesses this feature. This feature is much more likely to be vulnerable than the post comment on Facebook. Or if you have an application that allows you to connect your MySpace account, because nobody uses MySpace today, this endpoint of connect MySpace account more likely to be vulnerable than connect Facebook account. And how you can find those niche features and niche endpoints. So it would be beneficial to look for URLs in the JavaScript, APK, and IPA files, and to be mindful. Basically, just every time you see, like, you should try to understand the business logic. You should try to understand the app itself. You should take the mobile client and just start, try to understand what you can do with the app, which type of object you can create, which types of resources you can create for your own profile, which operations you can perform on these resources, and so on. The next thing I want to talk about is how you can find hidden versions using the predictable nature of APIs. So one thing that you can do is if you see a content type of JSON, you can give it a chance and change it to XML. And maybe if you're lucky, you'll be able to find a SOAP API. And SOAP APIs are probably more legacy, more likely to be vulnerable to attacks. You can also do something very simple and to leverage this nature to find old endpoints. Instead of like sending v3 to the endpoint of export all users, you can just change the v3 to v1. And something very interesting that I personally learned is that many times if you have access control mechanisms, for example, that this endpoint is an admin endpoint. It allows you to export all users. So v3 implements access control mechanism and returns 403 because you're not an admin. But many times the older versions don't implement the same security mechanisms. So this endpoint might just return you the full list of users, even if you're not an admin. I don't think we have enough time for the attack scenarios, but let's jump into the last part of the presentation, is what you can do if you got stuck during an API. So as a pen tester, many times you get to this barrier of like, you tried everything on the app And then you feel that you got stuck. You don't really know how to make progress. It's not easy. There is no like one approach what you can do. If it was simple, you wouldn't be stuck. But I can give you some tips how you can like expand your attack surface when you perform a pen test for API. So the first thing that you should do is to find more API endpoints, because like API endpoints are entry points to the application. Each one of them is a potential surface to attack, right? So I want to talk about two different concepts, like two different types of endpoints. I would call them wet endpoints and dry endpoints. So when we talk about wet endpoints, it's very simple. It means that you took your mobile client, you configured a proxy, use the mobile application, and you just see legit traffic from your client. So it's very easy. Like you click on the button to upload the profile picture, and you see behind the scenes an API call to update profile picture. So it's very easy to use this type of endpoints because you have all the information. Your client would send all the parameters that should be sent. But the main con here is that you have only access to the endpoint that your clients have access to. If there is like some type of client, for example, if there is some IoT device that uses the same API, you can't really use the endpoints, right? Because you don't have the IoT device. So, and then we have the second type of endpoints. You have the dry endpoints. You have the and those endpoints, it means that you have only full or partial documentation of the endpoints. You don't have active client that generates data into these endpoints. It's much easier to find a large amount of them, but it's much harder to work with them. Why? Because you don't really know what are the parameters that should be sent. So let's see some tips on how you can find more endpoints when it comes to wet endpoints that you can find from like traffic that clients generate. You can use multiple clients. You can use older versions of each client. APK Pure, it's a website that allows you to download older versions of APK files. You can use archive.com to find older versions of applications. You should try to use different environments, QA, staging, and beta. And when it comes to dry endpoints, basically what you can do is to scan the client files for strings that look like URLs. And if you see like a string that looks like URL inside the JavaScript or the IPA file or the APK file, you can assume it's a new API endpoint. Another thing that you can do is to look for exposed API documentation for developers. It can help you to find more endpoints. A few more random tips. Different protocols means different implementations. An application can expose REST, SOAP, Elasticsearch, GraphQL, and WebSockets at the same time. You shouldn't assume that they implement the same security mechanisms. For example, if the REST API implements a very strict rate limiting mechanism that doesn't allow you to perform like brute force on the login endpoint, don't assume that the SOAP API implements the same thing or the GraphQL implements the same thing. And many times, a non-prod environment like QA staging don't implement basic security mechanisms. Yeah, I think this is the end of the presentation. I want to give you a few more resources that you can use. The OWASP Top 10 for APIs. Obviously, you have this 31 tips for API pen testing that we published at Traceable. You can take a look at my Medium account and to follow me on Twitter to see those tips and many others. And I think now we have some time for questions.
Inon, before we go to
Renata, you're on mute.
Before we go to questions, can you comment on your participation in the OWASP virtual conference and the sessions that you are having there?
Yeah, definitely. So I have a session on advanced REST API exploitation. Some of the information that I shared with you in this webinar is in this presentation. And I also have other tips that I added only for the OWASP conference. So if you're part of the OWASP conference, I would recommend you to watch the session.
I just
to add?
added to the chat window the link to our Inon's session there, and Traceable also will have a booth at the virtual conference with some additional information about how we implement some of the things that Inon has described in the previous webinars. So I encourage you to come by, register, get some prizes, and look at some videos that way. And in terms of the questions, Inon, if you open the chat window, there are some interesting questions there, and I've marked some that we want to answer.
Cool. Yeah. So I see one question from Kemba is, how do I find other resources and endpoints? It's a good question. There are a few approaches. It depends. So first of all, if you have access to the clients, you can just use the client and to create different things. For example, if we talk about Google Drive, you can create presentations, and then to create documents, and then to create. I think they also have an option to create a Google Drawing. So just to use the UI. If you don't have access to the UI, something that you can do is to perform like a dictionary attack on the API URL. So they're like prepared lists of words that are most likely to be exist in endpoints. So dictionary attack would basically you give the base of the API like /API/v1, and then the dictionary attack would generate attack like different words to try to look for example, /document, /downloads, and so on. You can use Burp Suite or Zap Proxy. They have pretty good lists to do the same thing. Then I see another question. Are there any automated tools for pen testing APIs? So, I mean, there are many automated tools for pen testing. They have different types of support for APIs. I would say that if you want to perform a more successful API pen testing, I would recommend you to go with an IAST approach, like try to find IAST tools to perform the pen testing. Many times, Dust, like more like Dust type of scanners, kind of fail understanding the JSON and the JSON requests and JSON responses. So I would recommend you to use the IAST. Any more questions? Cool. I think we answered all the questions. Anything to add, Renata?
Yes, thank you. Thank you for coming, and thanks for a great presentation, Inon.
Thank you so much. Thank you, guys. Hope you enjoyed it. Bye-bye.